Hello, and thank you for joining us for today's webinar. I'm Alex Schuker, CTO at DrayTek UK Ireland, and joining me to present today is Mihai, one of our technical account managers. Some of you may have attended one of his drop-in sessions on ACS, but today Mihai's topic is going to be on quality of service. This webinar is our last webinar of the year, but it's not too late to catch up on our previous webinars, as we've got recordings of those available on the DrayTek website. If you go to the video section there, you can take a look at all the other webinars we've run this year, so I recommend taking a look there. We will be recording this webinar. We'll be sending a link of this out later, probably later on this week. So you'll be able to watch a recording if you happen to get interrupted, but also we'll be posting this onto the website as well. So this is a webinar that's designed for DrayTek users. Today is a deep technical dive into QoS. Hopefully you'll be able to, at the end of this webinar, have a really good idea about QoS functionality. And if I just go on to the next slide, we'll look at the agenda for today. We're going to start with just a general overview of QoS, what it's used for and use cases, and how QoS works from a network perspective to get you a bit of understanding of how it works in the background. And then we'll look at how it's applicable to DrayTek products, and also some specific stuff on hardware and QoS, because the hardware acceleration has some specific considerations to do with how QoS functions. And then Mihai will be looking at some best practices, some recommendations of how to set up QoS with some scenarios, and he'll also look at application QoS, which is a QoS that allows QoS traffic based on the application that is detected, which is quite a useful feature. So we'll look at that, and then we'll have a section on troubleshooting some stuff with QoS and VoIP, and also look at VigorACS to see how it can improve QoS using SD-WAN. So that's, I think, enough from me. I'll now pass over to Mihai, and he can take you through the webinar. Thank you.
Thank you very much, Alex. A very good morning to everyone, and welcome to this webinar. My name is Mihai Cretu, and I'll be your main host on today's presentation. Without further ado, let's have a look at some basic QoS functionalities. So what is quality of service? Obviously, the quality of the QoS is a term that refers to technology used to manage data traffic via the network. Using QoS, businesses can prevent disruption in the form of IP packet loss, delays, and jitter to voice over IP. QoS policing is essentially the traffic management of data packets traveling across a network simultaneously. To make things a bit clearer, let us take a real-world example of a traffic jam on a highway at a rush hour. All the drivers sitting in the middle of the jam have one plan: make it to their final destination. And so, at a snail's pace, they keep moving along. Then, the sound of an ambulance's siren alerts them that there is a vehicle that needs to get to its destination more urgently and ahead of them. And so the drivers move out of what now becomes the ambulance's priority queue and let it pass. QoS is usually applied on congested networks that carry resource-intensive data like video on demand, voice over IP, internet protocol, television, IPTV, streamed media, video conferencing, and very important, online gaming. Let's have a look at why the QoS is important. Well, first of all, latency reduction, because latency is the amount of time it takes for a packet to venture from the source to its intended destination. Ideally, the latency of these packets should be as close to zero as possible. Still, it can result in an echo effect for the recipient or overlapping audio if the latency occurs. Jitter reduction, well, jitter is another ill effect of network congestion and results in degradation in voice quality, audio, and video data. The irregular signal pulses often result in erratic distribution of data packets between IP addresses. Packet loss, obviously, packet loss prevention. Packet loss, as it sounds, is the loss of data packets because of a congestion on a network. Usually packet loss occurs when the router or switch has to disregard inbound data packets due to the overload, and that's going to be done until the issue is resolved. With QoS effectively in place, the steady stream of traffic is supported, meaning that packets don't drop out completely. Improved security, well, the QoS has the ability to block unwanted or suspicious data traffic in its path, sometimes acting as a firewall to make it a key component of a, let's call it, a more secure infrastructure. Just as an example, imagine that traffic that doesn't belong to any QoS rule will be regarded as best effort or very low priority, potentially making a DOS attack less likely. What VoIP QoS can and can't do? Well, can't control the routing. Obviously, even with best effort routing, quality of service is just one part of a broader set of systems that connect you to the phone system. In here, voice packets pass through many different network gateways and routers. Each hop along the way will affect the quality of service of your calls. In some cases, intermediary network equipment can strip away the SCP headers, and therefore we'll discuss this in the upcoming slides. QoS won't impact the performance of your internet service provider, ISP. In general, ISPs govern download and upload speeds, and this affects, obviously, the phone quality during peak time use. Also, the quality of service won't affect the audio compression. VoIP codecs determine the sound quality while conserving the bandwidth. Codecs can reduce latency and increase the quality of your voice calls, but it comes at a cost. You must provide a stable internet connection. And now let's see how quality of service works from a networking perspective. By default, routers handle the data packets following a first in, first out order, also called the best effort. This can create queuing issues across your network where bandwidth is at high use. So QoS solves this by dedicating network resources based on the type of traffic and the device. We can see on the second image that the router now is queuing the data in the relevant order and the right time intervals. Also, we can see on this image a quick representation on how untidy and jittery is the traffic without QoS. And when properly defined by QoS, the critical traffic is now having dedicated bandwidth without interference from other data types. Usually, administrators use three models to manage their traffic: integrative services, or INSERV, differentiated services, and the least common is the best effort model. Integrated services is a QoS model that works by allocating and preserving the bandwidth of a specific route on a network. Applying for resource allocation, then using RSVP, which stands for Resource Reservation Protocol, network devices can assess the stream of data packets to ensure there is sufficient space to accept the necessary packets. Arguably, the most commonly used QoS model, differentiated services, works by assigning value to each traffic type. Admins set the DSCP value ranging from 0 to 63 for each traffic type to classify it according to priority and group the traffic according to its traffic class. Data with a weighty DSCP value will take precedence over the data types or the other data types and reach their intended destination without delay or disruption. By the way, DSCP stands for Differentiated Services Code Point. Best effort is basically a less common use model and is the most simplistic so far. A router without QoS of any kind will treat the traffic using the best effort model. Let's have a look on how hardware acceleration impacts quality of service. Just to reiterate, this doesn't apply to the new range of routers. And if you'd like to find out more about hardware acceleration, I'd recommend to check our video section on draytek.co.uk, since there is an entire webinar focused on this topic, that thanks to Alex, who is the co-presenter on today's presentation as well. Looking at what impact hardware acceleration has on the older model, we can see quality of service can be used in conjunction with hardware acceleration. Bandwidth limitation is also not supported, and from a monitoring perspective, data flow monitor can't be enabled either. And you can see those steps are not required on 2765, 2865, 2927, and later routers. Now, if you must use hardware acceleration and you need to enable that, you can find the settings under hardware acceleration, and you can enable both NAT and IPsec accelerations. After that, under bandwidth management, quality of service, we have on the new routers models, you will soon have the ability to control how hardware acceleration and QoS are working. With the release of 4.4.0 firmware version, the following section will grant you granular access to how hardware acceleration and QoS are working together. Just to reiterate some disadvantages of the hardware acceleration use, the US defense is bypassed for sessions that have been accelerated. Bandwidth limit function doesn't work for sessions that have been added to the PPPA table. SD-WAN on reporting on applications data usage is going to be affected as well. Hardware QoS doesn't allow dynamic reallocations of class 1 to class 3 quotas. And no application QoS for inbound direction either. Firewall filter bypassed for packets already approved. And again, older models incompatible altogether with QoS, bandwidth limit, session limit, and data flow monitor. We will now be looking at various scenarios in which we might need to use QoS. All those scenarios are independent of each other, such as how to prioritize teams with quality of service, how to prioritize voice over IP on a network, and how to tag outbound traffic to be recognized as priority traffic as well. Let's have a look to some Microsoft documentations about how to prioritize teams. They recommend that the audio, video, and applications sharings have different DHCP classes, and also they use different TCP and UDP ports. All these must be translated onto the router's configuration. So let's have a look on how we do this. First things first, if the router is a non-DSL router, you need to perform a speed test to identify what the speed of the line is. This is a very important step in setting up correctly quality of service. If we have identified correctly what the speed is, then we can go to quality of service on the router's graphical user interface and define the findings on the relevant WAN. On this case is WAN 2. As you can see, WAN 2, it's enabled for quality of service. Direction is set to both, so traffic is going to be treated in and out for quality. The line on this occasion is 100 by 100 megabits per second. And I have assigned class 1, which is audio, in our case, 20% of the entire bandwidth. Class 2, which is video, in our case, 25% of the entire bandwidth. And class 3, just 15%, which is screen sharing, basically. You might want to alter these values depending on your priorities. So this is not something standard that you should follow. And now we need to add the class rules according to the team's documentation. Now we edit the first class rule. We give it a name audio, which we know is the most important thing, so we don't want to lose that at all. We set the TCP, the mode of transfer. The mode of transfer for audio is select TCP and UDP, and we define a range of ports from 50,000 to 50,019. And we assign the QoS class as class 1. Second rule, which is video, we again define the transport, the preferred method of transport to be both TCP and UDP. We select the range of ports for video, and we assign the QoS class number 2. And finally, after we follow the similar steps and assigning the correct ports, we can set for screen sharing the QoS class 3, which is even lower priority than class 2 and 1. Now we can see all the classes are well defined onto the class rule table. As a testing component, we can have a look at the status of quality of service. And we can see currently Teams it's in use. We can see class 1 and a little bit of class 2 are prioritized over class 4, which is others or best effort, basically. So traffic that's not classed on class 1, 2, and 3. Now let's have a look on how we set up voice over IP. So we are talking about IP phones that are residing on a particular network in here. Again, we need to define the WAN characteristics. We want to have both inbound and outbound traffic applied with quality of service, and we can define the classes again. Now we see in here that class 2 and class 3 have to be must have a value in there. Therefore, I added the smallest possible value to class 2 and class 3, meaning that others will have 88%, class 3 1%, class 2 1%. Those two classes are not in use currently, and class 1 is going to be in use, obviously, for our VoIP process. And as you can see at the bottom on VoIP prioritization, we have enabled the first priority for VoIP. And when this is enabled, the router will monitor the call quality and might reserve even more bandwidth if the quality is poor. However, the router will assure that non-VoIP traffic can always use at least 50% of the WAN's bandwidth. And this is not all. We need to add another rule for our DNS traffic. So we can define the name as DNS. We set the port number port 53. That's DNS. It's a service type, so it can be selected from the drop-down menu altogether, and assign the QoS class to class number 1, which is high priority. Okay, so now let's have a look at some statistics. We can see on both tables. So we have the status of the quality of service, and also we have some call records that can be checked. Firstly, quality of service for voice over IP. We can obviously see that works perfectly inbound and outbound, while a voice voice packets have been identified. And also on the call records, we can see some calls that have been made. We can see the internal IP address that have been used for that, and also the peer ID, the start time, and the duration of the call as well. And very important, delay, jitter, and packet loss. You should always want to see that screen as multiple zeros and nothing has been lost. The recommended way, in my opinion, would be to have a dedicated LAN for your voice traffic. So instead of having computers, printers and phones under the same subnet, you should instead have a separate or additional subnet for your phones. And then you can apply the quality of service very easily to an entire subnet, because you know on that subnet it's only residing voice. Therefore, you can identify that traffic as being very important and matched under the class 1 rule. Now, if we want to tag outbound VoIP with expedited forwarding, which per hop behavior shows that any traffic class with EF is given highest priority and is not queued, basically. EF provides low latency and low jitter. By the way, the ISP also must have this enabled. Normally, if you don't have an agreement of a sort with your ISP, the EF class is going to be stripped by them. Tagging outbound traffic with DSCP values will work if you control the entire routing domain, such as an MPLS network maybe. So let's see how we do this. Under quality of service again, we can add at class 1 on this occasion a predefined service type for SIP, which it's what we want to add to class 1. After that, we can tag the outbound class 1 traffic with the EF class, which stands for Expedited Forwarding. A Wireshark capture for EF tagged packets. You can use the IP.ds field .dscp =46 to filter any unwanted traffic, and we can see on this shot that the correct tag is added to the outgoing package. Let's have a look to application QoS quickly, because with application QoS we may easily restrict the bandwidth that any application uses. We can also reserve an amount of bandwidth for a particular application, and also saves us the trouble with defining the priority ports the same way we did with Teams, because all these applications are already predefined in the application quality of service field. So let's have a look to how we do this. Obviously, you are required to have the QoS enabled for a specific WAN with the correct values for class 1, class 2, and class 3. After that, you can move to application QoS, enable application QoS, and define your applications and the correct classes. Another thing to note is that on the newer router models, Teams is already a part of the application QoS, and you don't need to follow the steps we previously did, since this can be achieved by ticking the relevant Teams box. As soon as you tick those boxes and you class the action for the QoS to be class 1, 2, or 3, this is going to be added instantly to the quality of service for that class. Let's have a look to some troubleshooting steps. This might be useful, but it can be anything, but just some quick tips on how we overcome some issues related to voice and quality of service. First, inability to make outgoing calls. To fix this, you can try to disable SIP-ALG. Also, make sure you don't have double NAT or two routers preventing the flow of data packets. Inability to receive calls. Well, stun might be required on the phones, and you can check that with your SIP provider, or you can access the phone interface, search for the stun settings, and use a public stun server such as Google to see if that resolves the issue. Put your VoIP phones on a particular VLAN. Putting your VoIP phones on a VLAN might also fix the problem, or at least you'll get a better performance since the broadcast domain is just left for phones. Jitter or data packet loss. One quick way to improve the call quality of your business phone system is to look at your wired or wireless setup. Consider maybe taking calls using wired headphones instead of wireless ones. Probably the easiest way to address how to fix broken audio is to use quality of service. Dropped calls sometimes maybe drop because of the UDP or the user datagram protocol timeouts. This is basically the amount of time a UDP route stays open on a router or firewall. Applications that use UDP is like a shortcut to enable a fast stream of data without error checking are prone to this. The downside is that it's making them susceptible to firewall closing the connection and suddenly terminate the call. You can increase the UDP timeouts on all our routers if that's the case. Use the correct cabling. Sometimes poor wiring causes excess latency. And your ping should always be less than 80 milliseconds and the jitter should be less than 30 milliseconds. Anything more than that requires a full network survey to identify if the ISP is to blame for this. And now let's have a look on how Vigor ACS3 can improve quality of service by using software-defined networking. But first things first, let's have a look at what ACS3 is. It's a cloud-based solution that covers the entire DrayTek estate and will be the best suited tool, meaning that it can be accessed from everywhere. It has no theoretical limit on how many devices you can manage from there. You can use the platform for provisioning, feature that allows you to do certain changes globally, meaning that, as an example, if you want to change the admin password on all your devices at once, you can use the provisioning facility to achieve this. You can also monitor your devices, see the connected clients on these devices, and have a better understanding of which clients are connected to which network and for how long did they do so. For instance, if a device loses connection to the ACS server, then an alarm will be produced, an email will be generated, and you'll be informed about the current status of the device. Schedule maintenance gives you the ability to schedule a firmware upgrade and apply the upgrade on all your devices at once at a certain moment in time. You can also schedule a configuration backup that can be set as a cycle backup, for instance, every 2 weeks on all your devices. There are dozens of reports that can be created on there, such as LAN or WAN traffic overview, firmware overview, and many others. In addition to all of this, the SD-WAN or software-defined networking WAN is a key feature to ACS3, which allows a network admin to manage any combination of internet service provider, including VDSL Ethernet, LTEs, and VPNs on a centralized management system to get the most possible performance, effectively improving the utilization and providing more options when building and improving networks. In addition to optimizing the network utilization from different applications, it helps to simplify and give full visibility to the network management, obviously by monitoring services and applications passing to the network. Now let's see how we do this to the VoIP traffic. First things first, on the new, this can be applied just to the new router models that support SD-WAN. You'll be seeing a different screen with different load balance setup modes, all of which are suitable for an SD-WAN operation. On the general setup, you need to add WAN 1 and WAN 2. For this to work, you need to have multiple WANs enabled. And you need to add some destination ping addresses, such as Cloudflare or Google DNS 8.8.8.8 on each WAN link. And after that, after doing so, you can register the device to work on ACS, and also you need to enable SD-WAN for a particular network that you might have created in there. We are currently looking at a network called the London network, and by selecting it from there and then going to the network management section, we can enable SD-WAN for that particular network, meaning that any device residing on that network and that supports SD-WAN will benefit from the SD-WAN process. Now the profiles have been defined. The most important ones, the process of WAN and VPN, and also VoIP. And now under configuration, so just to make sure we are not onto the device configuration, we are onto the network configuration section. Under VoIP SD-WAN, we can enable that, and in case we want to change the most values, we can do that from there. In telecommunications, a mean option score is a ranking of quality of voice and video sessions, basically. And now, because the SD-WAN is enabled for London network, we can navigate to the SD-WAN section and have a look on which line out of the two currently residing on the 2927 lab router are better suited for the voice calls. And obviously the average MOS for the wireless one in this occasion take precedence over the wired one. Therefore, the entire VoIP traffic is going to be redirected through the wireless one instead, because it has low latency and low packet loss. Let's quickly have a look at what was covered today. We looked at the role of the QoS mechanism, why is QoS important, and what VoIP QoS can do and can't do, how hardware acceleration impacts QoS. We looked at various scenarios in which we might use QoS. We covered a little bit of troubleshooting and also SD-WAN and QoS. Thank you very much for joining us today. I will now hand over to my colleague, to Alex, to run the Q&A session with you. Alex?
Hello, Mihai. Thank you very much. That was a very interesting presentation, and we've had quite a few questions coming in during the presentation. You've kept us busy today, so thank you for the questions. That's always good. What we'll do is run through some of them now over the audio, so that others can kind of benefit from some of the questions and answers. So if we look at the first one, the first question we've got is, can QoS help VPN users remote user traffic? So if you've got a VPN user coming into the router, can QoS help with that?
So QoS with DrayTek VPN remote user. Okay, so there is a knowledge base article on QoS for VPN which we'll post to this chat. Did anyone posted anything? Or
yeah, well, I'll put that into the chat.
Obviously, so, you can enable prioritization on the router that the user is using, and then that's gonna be the case.
Yes, that's right. So the one recommendation would be to, on the router the user's using, put some QoS traffic on that. But we've also got a guide for kind of how to set up QoS for the VPN, but the far end, the router can only prioritize stuff that it receives. So if the far end has dropped the traffic for some reason due to that end, then it would be down to the QoS setup on that end. But we'll put some stuff in the chat that is a link to a guide that will be good for people to read on that. So next question is about kind of HTTPS. So now that kind of all traffic tends to be on HTTPS, so that's secured. The question is, how do we do different QoS rules for different types of services, because they're all use TCP 443, so they can't create an individual rule for all the different services. So do you have any recommendations on how to approach that?
That's a very good question, actually, and I'm quite glad I've covered a little bit of that. So application QoS can be a good solution for this if the application is something that the router can basically detect. Basically, other than that, my recommendation would be to find out the destination IP addresses that are being used. Obviously, the applications are using 443, but not only that. So as you can see with Teams, for instance, we use the wide range of ports. So you can always identify what ports some of the applications are using. Obviously, they are using 443 as well, but they might be using other ports. So by identifying that, you can at least partially, if not totally block, not block, actually, prioritize that traffic.
Yeah, and for really important services, you can sometimes look up the IP addresses and do it based on the destination IP. Even if there is load balancing, there tends to, in some cases, be a set number. It's a little bit different if something's in a cloud service where there's many IPs and also potentially using IPs that are shared. But it's worth considering just to look at what IPs you're using, because you might find in some cases the service is something that's predictable, that's using a set range of IP addresses that you could then put as a QoS rule. But as Mihai said, the app QoS is a really handy for that, because it allows it to be detected automatically. So next question is about some changes in the firmware. So someone said that they've noticed that on the 2865 and 2866, the QoS bandwidth setting has changed for the WAN one, for the DSL WAN. So in older firmware, it used to get the bandwidth automatically based on the sync rate, but now in the new firmware, it's set manually. And the question is, why has this changed, and what do we recommend?
Yeah, QoS usually was looking to the physical rate, but this isn't the precise method, because the actual rate can be different from the synchronizing rate. So it's been changed so that you set the actual expected sync rate, because in practice, on a VDSL line, the sync rate is reasonably stable over time, and it allows a more accurate value to be set rather than an approximation of the throughput based on the sync rate, if that makes sense.
Yes, thank you. I mean, it's something that when a router's first installed, sometimes the sync rate can change as it goes through a kind of training period. So it's one of the things that for doing a new install, it might be worth, if you're setting the QoS, to look at it again after maybe a week or 2 weeks to see if the sync rate has adjusted up or down, because sometimes when you first get a VDSL line installed, it might have a certain sync rate, but that sync rate might go up or down depending on how stable it is, because if there's disconnections detected, there's kind of automatic mechanisms that tend to adjust the target sync rate. So you might find that the sync rate kind of stabilizes a little bit over time. So if you do set it manually, then look at it again after maybe a couple of weeks to see if the rate is similar, just so you can tweak the manual QoS setting there. But thank you, Mihai. So another question here is about hardware acceleration. You mentioned hardware acceleration during the thing, but there was a question that was just kind of asking kind of what is hardware acceleration. So I think I can possibly answer that one. So hardware acceleration is a way to allow the router to offload processing of packets, so that it allows the processing to be done by a hardware component, which then frees up the router's CPU for other functions such as kind of VPN services, for example, which allows higher WAN performance and then allows those other functions to get the maximum performance. It's not needed for WAN links that are kind of lower than around 300 megabits per second, but it can be enabled on higher speed WAN connections to get that extra benefit in total performance. We've got a webinar recording that goes into hardware acceleration in more detail on the website. So if you look up go to the video section and look at hardware acceleration, there's a webinar that goes into hardware acceleration in detail, and also some of the drawbacks of it as well, and limitations. As kind of Mihai covered some stuff on QoS, but there's some other bits and pieces as well to be aware of. But it's a really useful feature that helps get a more speed out of the really fast connections. So hopefully that answered that. Another question here is about the QoS classes. Actually, there's a few that have come in on that, so we might cover a few on this. But the first one is the first priority class for SIP. Someone's noticed that in some cases they're seeing QoS traffic in there, even though there isn't actually QoS traffic in place. So they're wondering why is there some other traffic being included in this high priority class.
Absolutely, yeah. The router also puts some internal services into this class, so this is the highest possible class. The traffic sent by the router itself, rather than the clients behind the router, would be put in this class. For example, if you transfer a firmware file to the router via the router's web interface, this traffic is going to be given the maximum priority, basically.
Yeah. Okay, that's good. Thank you. And there's a few more questions that have actually just come in related to that. So one is about the different classes. So the question is about how the percentages work. So there's a few different ones, but I'll use one of these examples. Assuming there was, say, 15% allocated to class 3, and there was no other traffic that was currently ongoing that was matching classes 1 or 2, what happens to the spare bandwidth? Can class 3 use more than the 15% it's given, or is it limited to 15%?
Yeah, so as far as you don't have hardware acceleration enabled, the quotas will be reallocated between the classes, if I'm not wrong. Just when you use hardware acceleration, if you remember, we covered that downside of using hardware acceleration. It's the reallocation of quotas 1 to 3 is not possible. But other than that, yeah, the bandwidth is going to be redistributed if there is any available. Okay.
So the common example, I guess, with that is if you have class 1 with a big percentage and class 1's just not using it, then gets reallocated. And a follow-up question to that is if you have class 2 and class 3, maybe 10% allocated to class 2 and 10% allocated to class 3, and there's spare bandwidth from class 1, who gets the other bandwidth first? Which one gets kind of first refusal on the bandwidth?
Sorry, you have to repeat that if you don't mind.
I'm sorry. So if class 1 is set to, say, 50%, class 2 is set to 10%, and class 3 is set to 10%. If class 1 isn't using all its bandwidth and is spare, which of the other classes gets to use the bandwidth first?
Class 2 first, yeah, if that's in use, obviously, if anything falls under that class 2. If nothing is used by class 2 or 3, then others are going to benefit from that type of traffic.
Yeah, okay, that's good, thank you. And I've got some questions about VigorACS. One is how does someone get a trial of VigorACS? What should they do?
Absolutely, there are a few flavors of trials currently. So the best thing would be to email, I think, info@draytek.co.uk to receive a subscription link.
Mm-hmm. Yep.
So info@draytek. Yeah. Okay.
Good. And there's a question about VigorACS3, which is when is it going to be launching? We're in the process of that. I can kind of answer that. Yeah, it's should be available probably by the end of this year. we're just going through the kind of launch process of that, but we'll announce that very soon once we got the cloud version of that available for people to use. But I think that covers all the questions now, and it's 1:45, so that's a good time for us to close the webinar. I just wanted to thank everyone for attending, and Mihai for the informative presentation. If you've got any feedback or any additional information you'd like, just jot a note in the questions and we can contact you afterwards, but alternatively send an email to info@draytek.co.uk and we can get back to you as well. And if you've got any suggestions for future webinars, then there's a survey that is afterwards. Just add some stuff in there, and then we'll take a look at that. It really helps us with forming the future content, and we're looking at the webinars for 2022 now. So watch this space on any future announcements of our next webinars that we're going to be hosting next year. Thank you very much for attending any of the webinars this year with us. We hope you've enjoyed them. Goodbye.